Okay, so this is going to be a FizzBuzz Kata, but I thought I had a feeling we could just do it a different way than we've done FizzBuzz Katas before. I think this is a different solution. So I've set up the environment here. I guess we need to have, I've got guard running. One thing on the latest version of guard is in the guard file. Where is it? There's this new parameter called command that has to be passed in, called guard, or else it doesn't work.
So annoying.
Minor detail. All right, so that being said, let me get rid of the sidebar. Sidebar, there we go. And I think we're going to be doing all of our work in here. So I took the liberty of giving us a little bit of a head start. So we were going to have the FizzBuzz class, and it has to be defined. So let's see what happens if we run the tests. And we've got one test, and it failed. So I guess the idea that I wanted to try to explore with this was to try to do this in a more functional way, and I guess we'll let the people who know more about functional programming than I do determine how successful that effort has been. But I think that I'm coming to realize that one of the differences between the functional approach and the traditional object-oriented approach is that with objects, we tend to spend a lot of our time modeling one object. And then we kind of attach that into some infrastructure, either within the programming language or maybe within the execution infrastructure that is going to make that object scale. Because after all, normally with computer programming, you aren't building an object because you only have one of something. You're using a computer because you have many of them. You've got to process many of them. They're presumably similar in some way. But nonetheless, I think with object-oriented programming, we put a lot of emphasis on just trying to model that one object. And it's kind of like if you're building if you're trying to build a computer simulation in an ant colony, you spend all of your time just modeling the ant and not the whole social structure. You might only need a couple of functions to describe what an ant does, and the rest of it could all really be about modeling the colony. I mean, an ant doesn't really even exist on its own. So with that introduction, I'm not going to have a FizzBuzz number class. I'm going to have a FizzBuzz class that produces a sequence. So what I would like to do is have let's first of all get this test passing. I think we can do that by saying,
Is it failing?
Yeah, you already.
Yeah, I did that already. Class FizzBuzz. End. And we've got a passing test. So that's good. And now the next thing that I'd like to do with this is to let's specify.
You're on the wrong side.
Oops, yeah, I usually do it on the other side, so I'm confused. All right, I'll try to be flexible. Okay, specify that first 10 returns 10 items. So,
You have an extra quote in there?
Yeah.
first, oh, you know, the problem is that, is there a way to turn it off in Sublime so that it doesn't always try to give you your second delimiter? It usually puts it in a difficult place.
you're still, you need to
What happened now?
fix that line. You have a quote in the middle of your
Yeah,
string,
it's
but not at the end.
because of the way it's line analysis. Okay, there we go. All right, and now we're going to expect that we're going to make an object, FB, of class FizzBuzz, dot first 10, dot count to equal 10. Okay? Now, I think that's not going to pass. Fail, because undefined local variable. So we'll put up here let FB FizzBuzz new. And we now have a failure because there's no method called first. So what we will do is, instead of directly implementing the method first, we're going to include the enumerable module.
Yay.
And now, the enumerable module has an implementation of first, but that depends upon each. So the each method is now not defined. So let's def each end. And now we expected 10, but we got 0. So we now have to go about implementing each. And let's just first get the test to pass. Let's just do 1 to 10. Each do, we'll just put here a number. And we'll yield n. Okay?
You have a range inside an array. You should just.
Yes, it's supposed to be a range.
Yeah, but it should be parentheses.
Okay. And now we have 2 passing tests. All right, so now the next test is I want to do the same thing, except that I would also like this same thing to work for some other number of examples. So if I might, instead of just wanting the first 10 FizzBuzzes, I might like to get the first 20 numbers. And so when we run that, we find that we got only 10 back.
You only changed one part of the
You would
string.
change the expected value.
Ah.
And you should change the other part of the string.
Equal 20, first 20.
The comment above it should return 20 items.
Right. Items. Okay, so we expected 20, we got 10. All right, so maybe we should just make a larger number, but actually we could do this a different way. Why not use an infinite number? So what I'm going to do here is I'm going to create a local variable called underlying. That's the underlying sequence. And we'll define that as a range from 1 to infinity. Okay? And what we would like to do now is we will do underlying dot each. Okay? Now, there's a small problem with this. If I run this, I might not finish running before my talk is over.
It would work. Unless, the only issue is that underlying is the instance variable of your class right now. But
Yeah, well, the other issue is that although we're doing first, well, let's see, actually, maybe this is going to be okay
Yeah.
here. Maybe I don't need the lazy yet.
Try it. You just should switch to a constant to make it be a
Because if I
constant.
pull out the first 10, as long as I'm only just going to,
It should work. It uses a coroutine. It's
this
great.
may be okay.
But you should make it a constant. So you should
What?
change @ u to.
What? Which one?
You won't be able to access underline the way you wrote it right there. You could make it a constant.
Oh, I'm sorry. What I meant to do here was def
Ah.
initialize. Okay. So that may be okay. Let's see. And we return 20 items. All right, very good. Now, the next thing is that this is not very useful yet. So what I would actually like to have come back are to have this returns an array of arrays which consists of an integer and a string. And that way we'll be able to see what the number was and then what the string was, which should either be, if appropriate, FizzBuzz or FizzBuzz. Okay. And so what I'm going to do here is that I'm going to say, I'm going to look for an exception. So I'm going to expect that fb.first, and here let's just pick an arbitrary number. Let's set a new value up here, let n. For now, we can make it 100. So we'll take the first n of these. Each do, and then we'll use r as a loop internal variable, and then so we're going to raise an exception in various cases. So if r is not an array, or r.count is not equal to 2, or that the first element, r0, is not an integer, or if r.r1, second element, is not a string. Then we will raise not valid, and we may as well pass in the r variable there, so we can see what it was that we thought that wasn't valid. So we're going to expect this not to raise an error. So we're going to be good with this. All right, so we got an error, but we got a syntax error in this case. So it looks like there's a syntax error. What's wrong? There's a...
Oh, you have.
One more end.
Yeah. You never ended the .each
there we are, yes.
block.
There we go. And the very first one is not valid because it's not in the correct form. So what we would like to do is over here, what I'd like to do is to change this so that instead of having this each block iterating over just the numbers, I'm going to map this to the structure that I'm looking for. So I'm going to take n, and I'm going to turn this into n and an empty string. And then, let's see. I think we may need a backslash out here. And then we'll do dot each to yield n. Okay, so does that look good?
Yeah, you don't need the backslash.
I don't. Sometimes I'm confused about the situations in which I do and I don't.
I think dot map is not lazy by default, so it will.
Right, so this is the point where we're going to have a problem, because this is basically going to try, before it even starts, to yield the elements one at a time to the call program. It's going to try to map all of the positive integers into an array of arrays. So we can address that by using lazy here, which is a feature. How long is that actually in
2.0?
2.0.
In 2.0 in Ruby?
Yeah.
Okay. Now, you gave a talk, Jason, on this a few months ago.
I gave
You
a
did
talk
your-
on laziness in Ruby, but
you
prior
did
to
your own
that,
implementation of this, right?
well, not of that. I implemented a stream, which was a lazy linked list.
Right. Okay.
Which,
So anyway, this feature is really only applies to arrays. No, to enumerable.
it's enumerable. Yeah.
Yeah. So let's see if this works. And we passed. Here we go. All right, so now we have the right kind of structure. And we'll move forward here. And what we would now like to have happen is that it says Fizz if divisible by 3. So again, what I'm going to do here is I'm just going to test the elements as they come through. So we're going to say expect, again, fb.first n each do r and here we want to say if R0 is divisible by 3, so R0 mod 3 is 0, and Fizz does not match R1, we're going to raise drink.
What are you doing?
Huh? Let's just have a problem with this. Okay. So it's a drinking game, right? In principle, FizzBuzz, right? So let's try this.
Was that logical XOR? Or
Did I make,
goes in the
it looks
sentence.
like I made another mistake.
I think you meant to write ampersands instead of percentage.
What did I do? Oh, yes,
I
that's.
always want to have that.
Here.
Ampersand.
That's a different kind of off by 1 error.
Yeah. So if it's divisible by 3 and the text doesn't say fizz, then we will raise the drink error and say what was correct. And it looks like, and then we have to type here not to raise error again. And now we got an error because 3 is divisible by 3, but it returned the empty string. So now we have to solve this problem. And what I'm going to do is I'm going to create, before we solve this completely, I would actually like to create another test. So I'm going to create another method called, I'm going to describe append if divisible by, and then the number, the string, and the array that was being evaluated. And so move that, okay. So what we want this thing to do is it adds fizz if divisible by 3, if divisible by n, and we're going to expect that FizzBuzz append if divisible by 3 and fizz is the string that we're appending, and our sample array, say 6 with the empty string, we're going to expect this to, and here I do think I need this, right? Equal uh, 6 and fizz. So do I have the right number of parentheses here? Let's see. I expect FizzBuzz append if divisible by 3, passing in fizz and that array
Your
to equal.
parens are mismatched.
Excuse me? Yeah, I think this is correct now. And maybe we should just split this in the middle so that it fits on the screen. Eric?
Maybe throw another end in there just in case.
Yeah, why not? Let's just do it.
What? Oh, yeah.
Okay. All right, so,
Never hurts.
and we can also have, the contrary is it returns unchanged array if not divisible by. And here we'll put something rather similar. We're going to expect FizzBuzz append if divisible of 7, and this thing to equal 7, and the empty string, right? Looks good? Okay, so we've got some failures because we have no method error for append if divisible by. So let's go back over here. And what we will do is we'll actually define this as a class method. And this will take n, s, and r. And this thing is going to return r unless r sub 0 mod n is equal to 0. Otherwise, it's going to return r sub 0 and r sub 1 plus s. So it's going to append the string to R1, which in the case of our test is being passed as the empty string. So let's see if this works. And we now only have one failure. So our helper function now works. So now to correct the test that we were trying to get to pass originally, it says fizz if divisible by 3. Now all we have to do is here add another map. And we're going to map R. Let's see. And here we're going to do self.class dot append if divisible by, and we'll pass 3 and fizz and r. And let's see if parentheses came out correctly, brackets. Is that looks good?
Yeah.
Okay. And now we have 7 passing tests. Okay. And now you can see, I think I'm about 1 minute, I have 1 minute to go. Maybe we can still add in another, the next line here without test, just in the interest of getting to the end. But we will now have append if divisible by 5, buzz, and now if we exit out of guard and we just go into IRB and we let's see, we require dot Kata.
You actually didn't have to exit out of guard.
Oh, is that right?
Yeah, because that is basically, and the guard prompt is a enhanced IRB.
Oh, yes, that's right. That's the one that begins with P, right?
Pride.
Hmm?
Pride? Pride?
Yeah, isn't that that's prized? Yeah. Okay. So anyway, if we do FizzBuzz dot new dot first in the number. Another nice feature to add would be to actually write out the number in words in the string that's returned. But that could be another kata in itself. So anyway, thank you very much. I'm curious, what is the functional approach? Not sure.
I mean, it's all pure and referentially transparent. So,
Yeah, well, I mean, the thing that to me made it more functional was that at no point were we completely constructing, we weren't really ever constructing a single object that was going to encapsulate all of the knowledge to, to turn a particular number into the correct representation. Instead, we simply had functions which did part of the job, and we were processing the sequence. And then we processed that sequence through a series of functions which transform that sequence into what we want. And the whole focus of this is that we're actually interested not in taking 73 and determining whether that's a fizz or a buzz, but producing the sequence of numbers from 1 to 73 represented in a FizzBuzz. Again, I don't know if that makes it functional, but it's somewhere moving in that direction. I use functions anyway.
I have a minor picky comment.
Yes.
At the beginning, if your test was failing, it really wasn't failing. It was crashing. Your first test, where you said that you expect FizzBuzz to not be nil. It's never nil. It was never nil. So that
Yes,
test-
it was.
No, it wasn't nil.
it was undefined.
That test just failed to run.
Oh,
It was an error, not a
You could
failure.
have said expect it to not be 5, and it would have been the same.
okay.
This is a dangerous thing in general. I noticed I do this a lot where I write a test and I quickly check, oh yeah, it's failing, and I write a bunch of code, and I go back and run it again, and I realize, oh wait, my test was just crashing because I wrote it wrong.
Yeah, it is actually helpful. It is actually helpful to read the text of the error message. Yeah.
I feel like I would have just written one test that just tests the first 20 things of the output, and if those are all good, then I believe that's an adequate test of the algorithm. So,
Well, that would be one way to do it as well. Yeah, because I was going to write another test over here, Matt, saying that checking whether the numbers that were divisible by 5 had buzz. And then another one saying confirming that if the number is divisible by 15, then the text is FizzBuzz.
I have another comment.
Yes.
When you test something like append,
Yeah.
in your example, you just started out with an empty string. But I think it's a better test if you throw some random text into there. Put A, B, C, D in one of them, and D, E, F, G in the other one.
That's true.
yeah.
Cool.
All right.